This is Walter Leite, and in this video I will overview sampling methods. Sampling is a process by which we select a subset of individuals from a larger population to participate in a study. The ultimate goal is to draw conclusions about the broader population based on the sample. To do this effectively, it's essential that our sample is representative of the entire population. Various sampling methods exist. They all have advantages and drawbacks, and the technique you choose will determine the margin of error, also how much you can generalize your findings. Okay, so these are some key definitions related to sampling. A population refers to the entire group that you're interested to study, and the target population is the precise definition of who you want to generalize your survey for. The observation unit is an individual that the measurement is taken. Sample population are those that we have a chance of sampling because they are in the sampling frame. The sampling frame is the list and with contact information for the population. So the sampled population has to be represented in the sampling frame. The sample is what we actually take, and sampling bias is the probability of observing some groups in the population when the probability is 0. And sample variance is the difference between samples of the same population. So that's not just natural variability. We want to try to obtain probability samples when possible. Probability samples rely on random selection, which gives each member of the population a known and non-zero probability of being chosen. The randomness is a crucial part of a probability sample. Common types of probability sample include simple random sampling, systematic sampling, stratified sampling, and cluster sampling. No probability samples is when you don't know the probability of selection of each individual. So as in probability samples, we have simple random sampling, systematic sampling. Systematic sampling is really the same as simple random sampling. It's just a method to obtain a simple random sample. Stratified sampling, cluster sampling, and multistage sampling. And you can have combinations such as multistage stratified sampling, which is very common in national surveys. Simple random sampling is the most basic type of sampling. Every individual in the sampling frame has an equal and independent chance of being selected. This is achieved using random number generations. The result is a sample that represents the population well, assuming that the sampling frame is accurate and comprehensive. However, it can be inefficient for large and complex populations, but it's the basic method. We judge all the other methods in relation to it. There are technically two types of simple random sampling. Simple random sampling with replacement, where once you select a member in the population, you put it back in the list so it can be sampled again. And simple random sampling without replacement, where when you sample an individual, you don't put it back. In practice, for surveys, we only use simple random sampling without replacement. Simple random sampling with replacement is used for some statistical methods, but not for surveys. Systematic sampling is an algorithm to obtain a simple random sample. So you can, because it's practical, you can use Excel to do this. You have to first randomly order your sampling frame. So if you have a list of names and emails in Excel, you randomly order that list. Then you calculate your sampling fraction, which is the number of individuals in your sample, let's say 300, divided by the size of the population, let's say 9,000. And your sampling fraction is the inverse of, you inverse your sampling fraction to obtain your K. So with a sampling fraction of 300 over 9,000, the sampling fraction is 1 every 30th. So if the desired sample size is 300, then your K will be 30. Then to select a systematic sample, you choose a random starting point at the list. You then select every 30th individual in that list. If K is not an integer, you can round it up or down. So a systematic sample is a simple random sample only if the sampling frame was randomly ordered. Stratified sampling involves dividing the population into distinct groups or strata based on key characteristics like age ranges, education levels, or regions. You then randomly select samples from each stratum, either in proportion to the size in the population or disproportionately. So that's you have two types, right? You have proportional stratified sampling or disproportional stratified sampling. For either one, stratified sampling ensures all groups are represented, improving the precision of your estimates and allowing for subgroup analysis. Stratified sampling is particularly useful when certain groups may be overlooked, so you can oversample them. It's important to have in your sampling frame information about the strata, or else you cannot do stratified sampling. So for proportional stratified sampling, you use the same proportions, same sampling ratio for every strata. So for example, if you were sampling 5% of the population, you will sample 5% for each strata. Disproportional stratified sampling, you oversample. So for example, it may be that for if you are basing sampling population studies stratifying by whether they have a IEP or not, maybe you sample 10% of those that don't have IEP and 20% of those that have an IEP. And the objective of disproportional stratified sampling is, if you have a smaller group, you obtain a larger sample of it, but which will allow you to obtain estimates that are more precise for that smaller group. So to illustrate stratified sampling, suppose you are surveying teachers from both elementary and middle schools. So you stratify by type of school. First divide your population by school type and form two strata. Then we randomly select a specific sample from each strata. So this method ensures that both elementary and middle school teachers are represented according to the actual population proportions. But you could have chosen to over-represent, let's say, middle schools, and that would be a disproportionate stratified sample. So for disproportionate stratified sampling, you over-represent certain groups, obtain representative estimates of characteristics of minorities, but you have to compensate. You also can be used to compensate for known differences in response rate. Cluster sampling is often used when it's impractical to create a list of every individual in the population. So in other words, when you don't have a sampling frame of individuals, but you can create a list of clusters like schools and neighborhoods. You begin by listing all clusters in the population, then randomly select a subset of clusters. In cluster sampling, every member within the cluster should be surveyed. Now, in multistage sampling, you first sample clusters and then you sample individuals within clusters. Cluster sampling is less precise than stratified sampling because your standard errors and margin of error will be, well, the standard errors will be larger and the margin of error also will be larger. But it's more efficient for dispersed populations and cost effective. Okay, now multi-stage sampling, you will sample more than one time. So the first unit that you sample, let's say you sample clusters, that's known as primary sampling unit. And then the second unit you sample, let's say you sample teachers within schools, that is your secondary sampling unit. Multi-stage sampling allows you to handle large, complex populations and balance practical constraints. It's common in national surveys to combine multi-stage sampling with stratified sampling. So multi-stage sampling increases the margin of error, like increases your confidence intervals. Stratified sampling decreases your confidence intervals. Therefore, by combining them, you may get something that's similar to simple random sampling. This is a diagram just illustrating cluster sampling. Notes that within clusters, all individuals are sampled, as compared to multi-stage sampling, where you have the primary sampling unit, which is schools, so some schools are sampled, and then the secondary sampling unit, where just some students are sampled within schools. This is a comparison of the sampling methods, and taking simple random sampling as a standard, which for sampling frame it requires an individual list. Stratified sampling provides more precise estimates, so smaller confidence intervals, but because you need to divide the sampling strata and be sampling some people from each strata, the cost of data collection is higher, and you need the strata information in the sampling frame. Now, cluster sampling is less precise estimates because the standard errors will be larger, but because you only have to reach some clusters, not all clusters, the cost of data collection will be lower, and you don't need contact information for all individuals, only for those individuals within the clusters you select. Now let's talk about non-probability samples. So non-probability samples, they include several distinct types. Covariance samples involve gathering data from easily available subjects, such as students in the classroom or people in the mall. It's quick and practical, but you cannot generalize your findings to any population. Snowball sampling starts with a small group and uses their referrals to recruit more participants, which is helpful in reaching hidden and hard to access populations. Quota sampling seeks to match the proportional characteristics of the population, but that doesn't make it representative. It's still a non-probability sample, so the probability of selection is unknown. There is no random selection. Because they lack randomization, these methods have potential for bias. So quota sampling is usually is used for marketing, and it's based on finding specific proportions in the population and obtaining a convenient sample for each quota. So in summary, non-probability sampling methods, you are using available subjects, and you don't know if they overrepresent or underrepresent a characteristic in the population, and so you don't know how well your estimates represent the population. So these are good for studies that folk do not really aim to represent the population.